Hi there and welcome back to Triplicates and part 8 I believe of the battery charger cum tester, the super battery charger. So rather than have the thing, get rid of that one, rather than have the thing flopping about all over the bench, I've put it down on its bit of board it was originally going to sit on and still going to sit on. So this blank bit of error board here is going to have two, well, an AA and a AAA battery socket, a good ones, and it's also going to have the power connector on and some kind of a connector off to doing like drill batteries and things. But for now that's just glued down with double-sided foam sticky. So we're ready to go, and I've had it running on a battery just to test it. So let us look at what's going on the computer. Okay, so I have been working on the software a bit and just getting some of the run, stop, reset logic sorted out, and we now have indicators to tell us what it's doing. So it's running now and the display is in live mode, and apart from that just a bit of debugging, and I have a measure 1100 milliamp hour nickel metal hydride AAA battery capacity, measure capacity program. So just see what it does. It charges the thing up to 1.5 volts, and we're going to look into how we measure when the thing's fully charged. But for now we're just going to say 1.5 volts or 10 hours, which comes soonest. Then we're going to discharge it to 0.9 of a volt, so that's 0.9 of a volts monitor with drawing no current, and we're going to discharge it at 200 milliamps. Then we're going to charge it back up again according to the same scheme, and then we're just going to monitor mode. And it's been running a bit on one battery, and I'm going to put a fresh battery in and start again. So yep, here we have it. It charged the battery up to there, and now it's discharging the battery here. And I am going to stop that and put that battery to one side and start with a fresh battery for the purposes of this video. And speaking of this video, it's going to be a little bitty because I'm going to have to record a bit of video, then put a battery on for 10 hours or even longer, and then record another bit of video. So it's going to probably take me a while to assemble the whole video. Okay, so I am now going to abandon this. We will look at that battery again. So I'm going to hit reset. Now the program is still in the Arduino. So now I am going to change this battery over. Oh, so that I put that thing back into the time monitor and forgotten to change it back, but that's in stop mode because neither of those LEDs are on. So I am going to pull that battery out and put it over there somewhere, and I have a battery in my trusty clock, which the tops come off. The battery holder in this. So this is a Duracell battery. So we're going to put this in, and we are going to press go. There we go. So it's 5-minute update time. So we got reset. So if I hit run. You see here the relay click over, and I've turned the camera off but the green light's on, so it's in charge mode, so we're good. So I'm going to leave that running for however long and we'll see how it gets on. Okay, so here we are, 29 by 5 minutes, 30 by 5 minutes is 150 minutes, which is 2.5 hours in. And yep, it didn't charge up for long because it was pretty well charged anyway, and now you can see it's discharging and the voltage is gradually dropping as it discharges. And I've run a couple of batteries just while I was working on the software, and I can already see by this one, because the monitor voltage and the run voltage, that's the voltage with no current going in and out of the battery, and the voltage when it's charging or discharging, because the difference between them is not small. That tells me this is quite a good battery. So we will leave it running, and we will see what happens when it reaches, it runs out of charge. Okay, so as you can see here, we are almost discharged. And when it runs out of charge, you can see the voltage under load just falls away drastically. And because there is a diode in series with the transistor, obviously a Schottky diode, once it gets down to whatever it is now, 265 millivolts, the diode comes into play, and even with the transistor full on, we can't draw all the current. So I might put a further criteria in for the discharge, that if the current drops to half what it's supposed to be, then yep, it's done, it's empty, it's discharged. And you see, although the voltage under load, the run voltage, is dropping off radically here, actually once you take the load off, the voltage goes back up to a higher value. There's quite a gap here, but you know, down at whatever it is, 1/4 of a volt, it's pretty useless in terms of powering anything, so I think we can call it done at that. So hopefully it'll keep going enough to drop the monitor voltage down to 900 millivolts. I mean, I could put the monitor voltage up to a volt and say once it's at a volt it's pretty much done, and that would solve the problem. Anyway, the monitor voltage is at 927 millivolts. Hopefully next time round it'll be at 900 millivolts and the thing will switch over and start charging up again. Okay, and here we are. We've charged our battery up. It took a while because it was discharged, because previously the system fell over somewhat when it was discharged. So, and we discharged it here, and down here, you can't see that because that voltage traces are in the way. There we go. So it has, the current has dropped down to half, because that's 200 milliamps discharge and 100 milliamps charge, so the current's dropped down to half, and it's gone back into charge mode, and it's charged up all the way along here, got to 1.5 volts and turned itself off into monitor mode. Excellent. So if we now go action, analyze, it's charged up 669 milliamp hours, it's discharged 654 milliamp hours, and it's recharged itself 632 milliamp hours. And it's supposed to be an 1100 milliamp hour battery, so either the battery's faulty or maybe I am not charging it up enough. So shall we look into how you detect that a nickel metal hydride battery is charged up. Okay, so successful, but we have two sort of issues we need to look at. How we sense the end of discharge, the battery's actually run out of charge here, and how we sense that the battery is actually charged up here and here. Firstly, let's look at discharge. Well, this is the saved, this graph saved as a CSV file, and this is the end of the discharge, and we can see the monitor voltage is dropping, but not very much, so that probably isn't the best thing to sense, whereas here the voltage under load has just completely died to half a volt. So having decided to only test voltages in monitor mode, we actually, I think, need to test voltages in load while it's loaded up, and you can see it's discharging at around 200 milliamps, and it's actually finished here when the current's gone down to 88 milliamps. So I'll leave that on for now, but I need to change that so we can test while it's under load, and that's what we want. We want to know it's run out of charge. If the battery voltage drops to a certain level under load, it won't run anymore, whatever's powering the battery. So probably about a volt under load, we'd call it. And so I've got up the nickel metal hydride Wikipedia page here, the font of all wisdom as ever, and it does warn against over discharging, especially in multi-cell batteries, where if one cell goes flat, the other cells can push current through it the wrong way, which can damage it. So that's discharge. Let's go on to charge. So I have charged up till 1.5 volts is reached, and said it's charged at that, but the capacity does seem a little low for a good battery, so maybe it's not fully charged. Now let's go, here we go. We can charge up to the delta V method, where the voltage drops once it's fully charged, but looking at this, that only seems to work when the thing's charged up very quickly. It's about an amp for one of these, which I'm not sure I particularly want to do. And in a multi-cell battery, they might not all charge at the same rate, or they might not all have the same capacity, so it might be hard to detect, so I don't really want to go into that method. Another method is delta T. While it's charging, you're obviously putting current in at a voltage, so you're putting energy in, and so while it's charging, that is being stored, the energy is being absorbed and stored. When it is full, it's not storing energy anymore, so the energy is simply heating the battery up, so we can detect when it's full by simply detecting when the battery gets warm. So I might have a look at that in future. So let's have a look at what a couple of manufacturers say, and this is our friends at Duracell, who say their standard charge is 16 hours at 100 milliamp, or capacity over 10. So we're going to try that next and see how that works for us. And so here we have a Philips 1000, which interestingly, they seem to be pretty honest here. They say it's 900 minimum and 1000 maximum. So the headline, well, yeah, fair enough. And they are saying, based on IEC 619512, have a look for that, and their standard charge is 15 hours at 90. And here is a PDF of IEC 61951-2, which is a preview, not the full document, and yep, discharge performance. It tells you all about them and how they should work, and they should be stored and what size they should be. And the full version can be obtained here for 332 Swiss francs, which is 272 British pounds, which is a very untriplicate price. So sadly we won't be, Mini doesn't approve either. Sadly we won't be investigating that in more detail. Alright, so I decided I'm going to use the same battery since we've already tested and we already think we haven't fully charged it up. So here is my new scheme. I better save it. 16-hour charge. Save. Right, I'm going to make this. Firstly, we are going to discharge it. Stage 0 discharge down to 1 volt, monitored at 200 milliamps. Then we are going to constant current charge it at 100 milliamps. The end voltage will be 2, which we will never reach, and we're going to do that for 16 hours. Then we are going to discharge it again to 1 volt at 200 milliamps, and then I am just going to actually test the trickle charge for 10 hours, because I'll end up stopping it before then, at 20 milliamps, just to see what that does. And then it'll go into monitor mode if it gets that far. So let's just check through that again. So we're going to discharge it to 1 volt at 200 milliamps. We're going to charge it for 16 hours at 100 milliamps to 2 volts, which it should never reach. Then we're going to discharge it again at 200 milliamps down to 1 volt. And then we're going to trickle charge it for 10 hours at 20 milliamps just to put something back in it. And if I still haven't taken it off at that time, we are going to leave it in monitor mode. Right, so I shall save that again because I've not edited it. Save. I shall send it to the Arduino, which is now in stop mode. Yes, it's still resetting it. I shall just reset it again just in case, and we will hit run. So I largely left this going and did other things because it took the best part of 24 hours to do this whole run, and so this is my recording of what happened. So discharge here and then 16 hours charge here, and you can see it gets up to a level here, and I don't know what that spike was, suddenly went up for one reading. Call it a blip, eh? And it dipped again here. Is that the reverse delta V we're seeing there? Who knows? So let's analyze it and see what we've got. Well, measured battery capacity 773, which was better than the 670 I think odd that we measured before, but I'm not sure it justifies. I mean, we measured 672 when it started because I think it was pretty fully charged. So whilst yes, I think charging it for 16 hours does get a bit more charge in, I think charging it for half that up to this voltage here is probably good enough and takes half the time. So I have the CSV file of that up here. Okay, so you can hear it, see here it goes on at a level and then ramps up quite quickly, so I would call that voltage charged probably, which is about 15.5, 15.6 on the monitored voltage. So I think I am going to say maybe 15.6 is good enough. Is charged up enough for us. So now I am going to try some couple of other batteries. I'll try an AA and I'll try a drill battery, and then I will go through off camera probably and just go through all the batteries I have and test them. I should also point out that this is not a new battery. And I have no idea how old it is, so if the capacity isn't up to the original spec, it's not entirely surprising. So okay, we have, go back in here, measure capacity, which charges it at 250 milliamps till it's 1.55 volts and discharges it at 200 milliamps. Let's call that 250 till it's 1 volt. Then it charges it back up again, then it'll trickle charge it for 10 hours just to make sure it's topped up if I've gone away and left it. After that it'll just go into monitor mode. So we're going to save that because I've modified it. We're going to send that. Okay, we're going to reset, shouldn't need to do that, and we are going to run. So that is charging it up and we're waiting for data. So I'll let that run through and bring you back and show you the results. Okay, so we've got our 2500 milliamp hour AA nickel metal hydride, and we've charged it up, but it was already pretty much charged. We've discharged it on both at 250 milliamps, and we've recharged it up at 250 milliamps, and here it's just on trickle charge. So shall we see what our figures are? So 2405, that is not bad at all for measured battery capacity, and I've actually charged it up less. So I guess if we did not going to discharge more than we've charged it, but we're going to leave that one for now. I might come back to doing repeated charge discharge cycles and see exactly how that goes, but that's pretty good, and we're pretty sure that battery is good. 2400 for a 2500 battery, I'm going to call that good. And here we have a similar, but I think somewhat older battery from the box of batteries that I think are actually Duff, but I've been saving to try when I've got this thing up and running, so we're going to plonk this one in and try that. Okay, so here is our suspect battery that the battery charger wouldn't charge up, and I've run it and it's charged up, it's discharged and it's charged up again, and now it's on trickle charge. So what's the matter with it? Well, first up we see there is a big gap between the monitor voltage and the run voltage, which implies that the internal resistance of the battery is rather high. So I've modified my analysis, which calculates it, an average value for it, and yeah, the measured capacity on discharge is 1753 and it's charged at 2, so that's not bad. I mean, I would take that as on 2400. I normally, if it's anything over 2/3, I'll take it. But again, there's this internal resistance issue. So let's now compare that with the file we're going to load log. So remember that it's 1.39 ohms average. Yeah. And I've also, the last few readings, I don't take the average of where on the discharge where it's dying here, because I don't think that's a very meaningful place to be trying to measure the internal resistance with the battery stone flat. Right, okay, so now we'll go on to loading the good one we tested before. Yeah, that one. Open. Okay, so you can see those two curves, that's on the same vertical scale, and those two curves are so much closer together. So if we run our analysis, yeah, on the battery capacity we get 1/4 of an ohm only. So strangely, that's it, that with that battery, it's the internal resistance of the cell has gone up. Which means when you actually run it and load it down, the output voltage drops. So I am going to call that as a duffer, although it's holding charge. I mean, it'd probably be alright to run a clock or something, but I don't think I want it hanging around. Okay, so we've done a single cell. So let's have a go at a multi-cell one. This is my cheapo, it is, yes, Clark drill, that's machine mart for the English amongst you, and it is 14.4 volts, says on it somewhere. It doesn't say what the battery capacity is, but we're going to test this battery, and I suspect it's nickel cadmiums, because cheap commercial batteries tend to be nickel cadmiums for some reason. Don't know why they can use them when you can't actually buy them, not that I'd want to. So now normally this lot runs off wherever it is 12 volts because that relay's 12 volts and the Arduino doesn't really want to work much over 12 volts. So we have a second power input just for the charging, which is this, which is coming from the 10 which will be set to whatever the maximum voltage I want to put in is, plus a few. So let's get all this set up and see how it goes. Okay, so here's the battery, and the best way of connecting to the battery, I think, is going to be modifying the charger, just adding a couple of raw battery connections to it somehow. So let's see what's in it. Also interesting to find out what sophisticated a charger. So some minor interruptions. Get this thing apart. There are 2 screws lurking down these holes. 3. 4. What have we got? It's got a PCB. Wow. I wasn't expecting that. What's the PCB got on it? It's got an LED. and a diode. Oh goodness, a transistor. So those are the LED, those are two are grounds, that is the input voltage, which is that one, which goes through a diode to the output. I have to look on a magnifier. So I guess that transistor is just turning on the LED when there's a battery connected. That's all it's doing. Huh. Great. Okay, well I am going to connect two wires somehow, and then we can move on. And in case you were wondering, this is a circuit on that little PCB. So that is a 1N4007, slightly over the top for just under 20 volts. So the B-in comes in, charges up the battery, and then when there's current going through that raises that to 0.6 of a volt. So I missed the arrows off, but that's the LED. So it just drives current through the LED. So the transistor is nothing to do with the charging, it's just to turn the LED on when it is charging. Wonderful. So here it is, connected up. The battery's a bit. So I've got current sense wires, this little black and this little red. This charger has convenient holes coming out the top for some reason, don't know why, and this is the wires come out. This is the charging current, and the difference is the current sense is as near to the battery as possible. Come on, get in. There we go. So shall we try and set her up and see if we can get her to charge? So back to the computer. Okay, so we have a 14.4 volt battery, which is 12 cells. So we're going to first we're going to charge it up. We'll stick at 100 milliamps. In voltage, well, we said 1.55 per cell, so it's 1.55 times 12 equals 18.6. 18.6. So we're going to limit it to 10 hours for now. Then we're going to discharge end voltage 12 at 100 milliamps. Then we're gonna recharge it at 100 milliamps to 18.6. And again, we might limit it to 10 hours for now. And then we are going to monitor. And let's save that. Save. Right. Action, send. And we're just going to check we're getting 14 odd volts out of the voltage monitor before we start it. Okay, so we've left it in reset and we've recorded 14.4 volts, so we think it's going alright, and so confident am I that when we start charging and discharging there isn't going to be a puff of smoke and blown up electronics. I haven't even turned the camera on to the point that's pointing at the circuit. Alright, go on. Go on, I'd hate to miss it. Right, let's do it. Let's hit action. Run. It thinks it's charging. Yep, the power supply is drawing nearly 100 milliamps. What am I doing? So far she's looking good, so I'm gonna leave that running and see what happens. Okay, so here we are. We've been through the complete cycle with our 14.4 volt drill battery. So here it's charging, and it must have been pretty much charged up, and why it was seemingly such a high internal resistance I don't know. And here it discharges, and the charge, I set it to 18 volts monitor voltage, but you see it gets up to a maximum and comes down again, and that maximum is about here. It's like 15.6 volts, nothing like the 18 and a bit that I expected. So maybe they are nickel cadmiums and they behave differently to nickel metal hydrides. I don't know. And the second charging cycle, well, it ran 10 hours and stopped, but it was only 15.2, so I don't think it charged up all the way. I think I probably need to put it up to 200 milliamps, and it's a drill, it draws quite a lot of current. So I might revisit that later on. But for now, let's just analyze. So in fact it charged less than it took out, so it can't have charged it all up. It's charged 942 milliamp hours and it took 1374 milliamp hours out, so it can't be fully charged because there was more charge in that when I discharged it, and it was pretty well charged when I put it on. And okay, other thing to note, the resistance 1.79, well, there are 12 cells in there, and if you divide that by 12 you get about 1/10 of an ohm, so it's pretty good per cell. So that's it for this battery. I shall revisit it and maybe put it on at 200 milliamps and have another think how I detect the end of charging. But as I say, I'm going to leave it for now and use this rig to go through all my AA and AAA batteries and test them first. So that's it for what's been a fairly long video, but there you go. So before the next video I am going to solder those two on there, and these two are little temperature sensors, and I'm going to make a video on getting those running, just a little how-to, and I'm going to drill a hole in the bottom of the battery holder and stick those in so they're measuring the temperature of the battery, hopefully accurately, and I'm going to mount that on there somewhere, etc., and come up with some way of connecting to external batteries. So there will be another video on this battery charger, and hopefully I'll have some more interesting insights into charging of batteries by then. So until then, it's goodbye from Triplicates, and I'll see you on the next one. Goodbye.